Hello, welcome to Prairie Conservation Action Plan's Native Prairie Speaker Series. My name is Caitlin Rose, and I am the Stewardship Coordinator with Saskatchewan Prairie Conservation Action Plan, or PCAP. Today, Autumn Watkinson, Provisional PhD Candidate, Land Reclamation International Graduate School, University of Alberta, will be talking about sagebrush grasslands restoration for Greater Sage-Grouse recovery. Every month, PCAP asks someone to present either in the form of a webinar or an in-person talk in a Saskatchewan community on anything to do with native prairie conservation or species at risk. Stay tuned for our upcoming Native Prairie Speaker Series webinars. Jeff Keith with the Saskatchewan Conservation Data Center will be presenting about data sharing on December 6th at noon. That's next week. Ellie Knight, PhD candidate from the University of Alberta, will be talking about nighthawks and nightjars on Tuesday, January 23rd at noon. Details will be posted for both of these webinars on the PCAP website. I would like to take a moment to note that financial support for today's webinar is provided by Environment and Climate Change Canada, Eco-Friendly Sask, Ranchers Stewardship Alliance Inc., and SaskTel. In-kind support for today's webinar has been given by the University of Alberta. Just a reminder to all of our listeners out there, if you have any questions during the presentation, please feel free to type it into the question section of the webinar dashboard at any time during the presentation. Questions will be answered at the end of the webinar. Now, a bit about our presenter. Autumn Watkinson is entering the third year of a PhD in Land Reclamation and Remediation at the University of Alberta. She is a member of the Land Reclamation International Graduate School. Autumn has over 5 years of experience in land reclamation with past and current projects in mine reclamation, soil development, protected ecosystems, and habitat restoration for endangered species. Autumn is passionate about science communication. She volunteers with organizations at the U of A to deliver educational, science-based presentations to elementary and high school students in Edmonton. And she was a finalist in the 3-minute thesis national finals in May 2007. So I will turn it over to Autumn. Autumn, if you can hear me there, I've just passed the control over to you.
I see that, and I think that you should be able to see my screen now.
Yes, we can. Perfect.
Okay, great. So hello, and thank you for joining me in the webinar this morning. I'm really excited to talk to you today about the research we're doing in Grasslands National Park on Greater Sage-Grouse habitat restoration. Before I get started, I'd like to take this time to acknowledge all the people who've been offering assistance throughout this project. Without them, much of what I'm going to tell you would not be possible. So first, my co-supervisors, Dr. Ann Nath and Dr. Shelley Cruz, Grasslands National Park, specifically Laura Gardiner and Dr. Stefano Lucioli, my field assistants, Abigail, Adam, Ashley, and Jordan, and I'd also like to recognize Parks Canada, the Land Reclamation International Graduate School, the NSERC Create Grant, and the University of Alberta for providing funding for this project. So this is the reason that we're here doing all of this work and why you're listening in this morning. For those unfamiliar, this is a sketch of the Greater Sage-Grouse, and its current situation in North America is not so good. Greater Sage-Grouse populations have been declining for the past 100 years or so, but since the late 80s, their populations have started to decline very rapidly, which you can see depicted here in the graphs showing population declines of grouse in Alberta and in North Dakota. Declines were so rapid that we've lost 98% of the population in Saskatchewan since 1988. In Canada, we have only about 350 Greater Sage-Grouse remaining. There are also populations in the United States, but they've also experienced these large population declines as well. And so historical estimates put the grouse population in North America in the millions, and today we're sitting at less than about 100,000. Because of these population declines, Greater Sage-Grouse has been designated as endangered with coast seaweed, the Committee on the Status of Endangered Wildlife in Canada, and that's been in place since 1998, and has been listed as endangered with SARA, the Species at Risk Act, since its inception in 2003. So when a species is listed under SARA, it makes it an offense to kill, harm, harass, capture, possess, and so basically harm any of these individuals of that species in any way. But a species listing under SARA does not automatically give protection to that species habitat. So in 2013, the Greater Sage-Grouse was the first species in Canada to receive additional protection under an emergency protection order because its situation is so dire. And the EPO, this emergency protection order, not only protects the grouse, but it protects the habitat as well. Which is really important because in Canada, sage-grouse habitat has been reduced to approximately 7% of its historical range, and it's thought to be a major contributing factor to grouse population declines. So what you see on the map here is the dark green is the remaining current range habitat, and the light green is the historic range. What habitat is left could be in less than optimal conditions. So habitat that is left, a lot of it's degraded or fragmented to some extent, and fragmentation includes roadways, trails, fence lines, all of which the grouse are very susceptible to. Sage-grouse, as their name implies, are sagebrush obligates, which means that they require sagebrush to live. So if you take away sagebrush, you have no sage-grouse. And so, unsurprisingly, the grouse's distribution throughout North America is linked to that of sagebrush. And if you overlaid a map of sagebrush distribution onto the one you currently see on your screen, they would overlap pretty closely. So let's talk about sagebrush for a minute because it's the keystone of Greater Sage-Grouse habitat. In Canada, we have only one type of sagebrush, Artemisia cana, or silver sagebrush, although there are more than 10 different species of sagebrush distributed throughout North America. If we take a look at the map on screen, we can see that we only have one subspecies of silver sagebrush in Canada, Artemisia cana, or plain silver sagebrush. Silver sagebrush can grow up to 6 feet, but it's most often found under 4 feet. It has many branches which converge underground. The leaves are silver gray, which is where the name silver sagebrush comes from. In the fall, sagebrush will produce flowering heads, which you can see sketched here and in the bottom right photo. And one individual is capable of producing thousands of seeds. However, silver sagebrush reproduces mainly from rhizomes underground or underground root systems. And this is important because it also allows this species to resprout after fire. So grouse have 4 distinct life stages, and they each require different but necessary amounts of sagebrush cover. If we look at the top bubble there, lekking habitat requires the least amount of sagebrush cover. So leks are a gathering of males, and they get together a day display for the females during the spring. And the Greater Sage-Grouse, they're known for their unique mating ritual in which they strut, puff themselves up, and they pop a pair of big yellow air sacs on their chest, and it produces this sound that can travel up to 3 kilometers. It calls 2 potential mates. It brings the hens in towards the lek. And of course, the less sagebrush around this area where the males are dancing means that they're more visible to the females. So it makes sense that there's not as much cover here as in other habitat areas. Oops, sorry. Nesting habitat requires more sagebrush, so that nests are protected visually from predators. Corvids, so ravens, crows, things like that, are the main predators of nests, and visual concealment is very important. Brood rearing requires a bit less sagebrush cover because when the chicks are young and growing rapidly, they need a lot of food, and so the hens move into more mesic or wet areas where there's less sagebrush cover, but where there's a higher density of forbs and invertebrates for the chicks to snack on. And but over winter, the forbs and invertebrates are covered with snow, so grouse rely exclusively on sagebrush to fulfill their dietary needs. And this is why the sagebrush cover requirements in this life stage are so high, as well as they have a height requirement because the sagebrush has to reach above that snow line. So because sagebrush is such an important and necessary component of sage-grouse habitat, my research focuses on developing restoration methods to improve the establishment, growth, and survival of seeded or transplanted sagebrush. The experiments I'm conducting address one of three areas that are very critical to sagebrush restoration success. So sagebrush population ecology, improving container growth of sagebrush, and improving seeding of sagebrush. So first I want to point out that all field experiments are being conducted in Grasslands National Park. This is because it's the home of the last two remaining Greater Sage-Grouse leks, or populations, in Saskatchewan. And if we situate the park onto the sagebrush map I showed you previously, we can see that it's smack dab in the middle of this Plains silver sagebrush range. I want to give you a bit of background about the area. So the park and the sage-grouse habitat is situated in the mixed grass prairie ecosystem on brown Chernozemic soil. Annual average temperatures are between 0 and 6 degrees Celsius, but in winter it can be as cold as -45 degrees and summer as warm as 40 degrees. There's not a lot of precipitation in this environment annually. It's considered an arid ecosystem. And areas in the park that have been identified as potential greater sage-grouse habitat have been subjected to many different land management practices, including grazing, so both bison and cattle, cultivation, haying, burning, and or flooding. So I want to briefly talk about some of the experiments I've been running and some of the applied work we've been doing to restore 75 hectares of sage-grouse habitat in Grasslands National Park. I'm going to follow the outline given here and hopefully tie this into a neat bow at the end, because it does get a little bit information dense in the middle, and try to show you how these different components fit together as we develop best management practices for sagebrush restoration. So the first experiment I want to talk to you about is focused on understanding the relationship between sagebrush growth parameters. Why this is so important is because if we want to restore, for example, nesting habitat, which requires 30% sagebrush cover, versus brood rearing habitat, which has 15% cover, we need to know how many individuals or what density to plant individuals at to result in that cover, and how long it will take to achieve that cover. Which means we also need to know about the growth of individual sagebrush and how they contribute to that overall cover, and not just the stands at a landscape scale. And currently where we're sitting is we don't have that information for this plain silver sagebrush, or this Canadian sagebrush, because a lot of the literature on sage-grouse habitat restoration is actually originating in the United States, where they are dealing with a completely different sagebrush species, which is a lot larger and has a completely different ecology. So with this growth information, I'm going to be building a model to help inform restoration so that we can achieve those habitat cover goals. For this experiment, I've been wandering around the park all summer, measuring the overall cover of sagebrush stands and growth parameters of all the individuals within those stands. So things like stem diameter, height, and crown cover of each individual. And in addition to that, I'm taking aerial photos from above of each individual, which you can see in this slide here, which will help to determine what cover an individual contributes to stand cover. And then I run it through this imaging software. It's the photo that you see on the left. And I can actually determine the square centimeters that an individual is contributing on a landscape scale. To determine age, it's a little bit more tricky. I'm going to be using ring counts. So I actually need to destructively sample a small subset of individuals to do this. So what you can see here is a sagebrush that's been excavated down, because as you saw in the sketch of the sagebrush before, it has a lot of branching occurring, and these branches only converge underground, so I actually have to dig the shrub out a bit before I cut it, and then I'll be sectioning that stem to find an area where there's a good area that I can do ring counts on these stems, which if you can look at this bottom photo, it's going to be a little bit tricky. But in this experiment, I want to relate stem diameter to age, so that in the future, to determine sagebrush age, all one will actually need to do is to go out into the field and measure the stem and not have to cut the shrub down. So that's one of the benefits of this work. So if we know about the population ecology of sagebrush from that first experiment, we can then work on improving the practical aspects of restoration. So we have the model, we know how many individuals to plant to achieve desired cover, but now we have to look at how we're actually going to do that. Well, current revegetation methods actually have very low success rates with sagebrush. Specifically, seeding results in just 5% success from previous studies that have looked at seeding in Saskatchewan. So I want to look at improving seeding outcomes, and one way we can do this is simply by improving seed germination. So increasing the number of individuals that actually germinate, or improving synchronicity of germination. So I experimented with cold stratifying seeds, which means exposing them to cold for different lengths of time, which theoretically simulates overwintering and may play a role in breaking seed dormancy. I also looked at physical scarification of seeds, which meant lightly rubbing the seeds with fine sandpaper, and this theoretically is supposed to allow the small stem to emerge from the seed more easily. And then what I was interested in is how these two preparation methods might influence germination of seed of different ages in both light and dark conditions, because the light conditions simulate germination above snow, because sometimes we will seed in the spring onto the snow, but the dark conditions simulate germination below snow, which is what actually happens when we seed in the fall. Obviously, the seeds get covered by snow, and they will start to germinate under the snow in the spring. So what I found from this experiment, and just keep in mind that these results are not statistically analyzed yet, but what I think I see here is that scarification decreases germination period, but in dark conditions only. So this graph is showing germination period on the y-axis in days. Well, on the y-axis, we see the cold stratification grouped by number of weeks, so 0, 5, 10, 15, 20. Scarification is indicated by the N or the Y, N being no, it was not physically scarified, and yes, it was. And the light bars represent germination in light, and the dark bars represent germination in dark. What we see is that no matter how long you cold stratify the seed, it doesn't seem to change the germination period. However, if we scarify, we see a drop in germination period, but only in dark conditions. So if you look at the dark bars, at the first two dark bars, you can see that it decreased, the germination period decreased by a day when we physically scarified, whereas in the light, there seemed to be no difference in germination duration. And that's a pattern we see throughout this time. So this is important because by decreasing germination period, we can target seeding to occur in smaller windows of time when opportune environmental conditions are there. And when we do this, we can be sure that most of our seeds actually will germinate during this time. Okay. So we can improve seeding practices, but we can also improve container growth or planting outcomes by growing sagebrush that have a better chance of survival after planting. So growing sagebrush out in these containers, in these little, what they're called root trainers, and planting them is actually a really common method for restoration in the prairies. But some studies have shown that 30% of these container-grown seedlings will survive, which is, it's pretty low when you think about the amount of time and effort that have gone into not only collecting the seed and then growing the seed out in the greenhouse, transporting the plugs to the site, and then having a bunch of volunteers come and dig a lot of holes. So what I'm trying to do is improve those outcomes so that more than 30% of seedlings will survive after planting. And I'm investigating nutrient loading as a method to achieve this. So essentially what nutrient loading is that we grow out the individuals in the greenhouse and we expose them to different nutrient additions week by week. And we see 4 different, I guess, nutrient addition regimes, I guess, here on the graph, in which all of the sagebrush are going to receive a total. Okay, sorry, I just saw that the audio connection was lost. So we see a total 200 milligrams of nitrogen is added to sagebrush, no matter which regime you add the nutrients to the plant with. But for example, we see one option to add nutrients to the plant is to give 200 milligrams of nitrogen right away, and that's represented by this single black arrow up in the top corner. Or we could give a constant amount throughout the whole experiment, so 20 milligrams for 10 weeks, which is represented by this white triangle, or the constant dose. However, the idea is that if we match the nutrient additions to the nutrient requirements of the sagebrush as it's growing, we'll get better results because we don't induce nutrient deficiencies in our plants. We also don't waste fertilizer or induce toxic growing conditions. So you can see this luxury consumption state in the middle here is actually ideal. And how we achieve this is to essentially cease vertical growth of the plant, which is represented by that flat line biomass. So there's no biomass being accumulated by the plant. And we can cease vertical growth by a hormone treatment or by inducing drought conditions. But we still add nutrients. So you can see that nutrient concentration is going up. And the plant is then storing these nutrients in its in the roots and the leaves. And this is predicted to improve plant survival once planted because the sagebrush will have extra nutrient reserves to help make it through times of drought. Okay. So if we jump back now to looking at another practical way to improve seeding, we can look to protect the seed from desiccation and provide an ideal germination and growth environment by developing pellets in which these seeds can be enveloped. So I haven't started this experiment yet, but I'm really looking forward to it. It's pretty exciting work, and it's inspired by the work of Matthew Madsen from Brigham Young University and his colleagues, who are looking into technologies to develop what they call soil pasta, which encapsulates big sagebrush seed, which, as I mentioned, is this different sagebrush with a different ecology that you find predominantly in the United States. So what I'm going to be doing is combining different materials in various ratios to form the pellet matrix. And these materials will include things like hydrogels, peats, or clays to retain moisture around the seed, fertilizer to provide nutrients, potting soils, natural soils, tackifiers, which essentially they're just less sticky and they hold the seed pellet together, and seed surfactant, which is actually allows roots to penetrate the soil more easily and have the water infiltrate into soil surrounding the seed more easily. And if these pellets can be successfully developed and improve seeding outcomes. They could potentially be deployed from helicopters, and large tracts of land could be restored much more quickly than if done by hand. So yeah, after I combine these various materials and different ratios, I'll test them first for structural integrity. So actually they retain that pellet shape, of course, is important. And if they do, the second step would then be testing them for germination and plant growth, and like you see in the farthest photo here, in a greenhouse condition. Okay, so as I mentioned before, Grasslands National Park is a mosaic of blocks of land that have been subjected to various land management practices. And we know that these different land managements affect soils, the hydrology in the area, plant community distribution, it goes on and on and on, and therefore are very likely to affect the outcomes of standard revegetation methods as well. So the last piece of this restoration research puzzle is to look at how the outcomes of our revegetation methods or techniques could be affected by the previous land management on this site. And if we know this, and we know how the land management then affects our revegetation outcomes, we can then adjust our methods to be more successful based on what has happened in that area previously. So I've set up research plots throughout areas of the park that have been exposed to burning, flooding, cattle or bison grazing, and actually areas that have been unmanaged for a number of years. And on these plots, I've applied spring seeding, spring planting, or fall seeding of a standard native species revegetation mix. And I'm also looking at a non-native plant control. So what you see here is an area of land that's been burned in Grasslands National Park. Myself and a field assistant conducting our vegetation assessment. It's a summer full of just counting stems of grass and IDing them, and then this herbicide application here in the bottom. And to assess how the land management affects our restoration, how we're actually measuring this is by looking at changes in plant community and abundance, differences in soil such as texture and nutrient content, so differences in the soil between sites. So how are the soils different in an area that's been burned versus an area that has been plowed for a number of years? And changes in the invertebrate communities at those sites. And this is because, as I mentioned before, sage-grouse chicks rely almost exclusively on invertebrates to meet their dietary needs in the first couple months of their life. So if we can also tack on a measurement that allows us to measure invertebrate communities and how well the chicks might obtain food or in that area, it's just a bonus in this research. So what you see here in the photos is myself and one of my lab mates fall seeding a small 2 by 2 meter plot, which is the size of our plots in the park. Spring planting, you see the photo here of the sagebrush plugs we planted, and here in the middle, this is actually how we sample the invertebrates. We have it's called a pitfall trap. It's simply a hole in the ground, and you put the deli container in there with it's sort of like a dilute antifreeze. It's strong enough to kill the invertebrates or the soil, basically the bugs, the beetles, the spiders, the ants, the things that will fall into this trap, and then we're able to collect that and strain out the bugs and look at them that way. Sorry, not bugs, the invertebrates. Okay. So as I also mentioned, we're not just conducting experiments and then greenhouse, which has been very generous. They provide 3,000 sagebrush plugs every year. And we're also seeding large tracts of area by hand, which is what you see up in the top left-hand corner, with forb seed that's been collected locally. And so far, we've enhanced 35 hectares of land in Grasslands National Park, and next year we'll be finishing up with the last 40 hectares. So if there's anyone out there who wants to come and volunteer with the park, we do this event in June. There's also some fence marking that happens, and we would be happy to hear from you and have you come and help us plant the sagebrush, see the park, learn about the sage-grouse habitat. So that was a lot of information to digest. Thanks for sticking with me throughout that, and hopefully this flowchart helps to bring all the pieces together so that we can see how all the components of the research contribute to restoration success and subsequently the recovery of greater sage-grouse. So what we see, what triggered all this research was the declining quality and size of the sagebrush grassland habitat, which causes the decline of the endangered species of the greater sage-grouse. So by improving restoration techniques to improve habitat, through sagebrush ecology, seeding and outplanting, and then applying at a on a landscape scale, we can develop these best management practices for sagebrush grasslands restoration. We'll have an enhanced knowledge of Artemisia cana or silver sagebrush ecology and improved restoration techniques for prairie communities. And with that, I'd like to thank you for tuning into the webinar. I would welcome any questions, and I'm going to turn it back over to Caitlin. Thank you.
Thanks so much, Autumn. Can you hear me okay?
I can hear you, yes.
Okay, sorry, there was just a glitch there. Thank you very much for the awesome presentation. It looks like we have a few listeners who have some questions. So the first one is a listener named Tracy. And what is the software called that measures cover?
Oh, so I'm actually using a image processing software called ImageJ, and it's just image and then the letter J. So if she's interested, you can actually download that for free. And what this software actually does is you take your aerial photo from above, and it can recognize the color differences, and you're able to then contrast it. And if you have something in the photo for scale, which I'm going to try and show you that how we worked with that. It's kind of interesting. As you can see in this photo on the right, I have this stick in the photo for scale, and each tick is measured by the centimeter, or 10 centimeters, I think, at this point. So that when you're taking a photo, you can then put a scale on there, and then it can then convert, calculate based on this black and white image that's generated, which you see on the far left here, what that actual centimeter squared is in the photo.
Awesome, thank you. A listener named James would like to know, how did you measure darkness under the snow? And it may not be as dark under there as you think.
Right, so I actually didn't measure the darkness under the snow. What I did for this experiment is actually I had, what you see in this photo here is the Petri dishes with the sagebrush germinating on damp towels. And this is half of the Petri dishes, and they were germinated in light conditions. So they were in front of a window, they had the light. The other half I actually just stuck in a drawer, so it was all dark. And I took that as more of a most extreme, I guess, situation where it was completely dark, and then anything in the middle for dark and light conditions. I think you can kind of, I guess you could try to simulate, but I didn't actually measure under snow. I was just measuring, or just putting the seeds in a light and dark condition to sort of simulate above and below snow. But that's a really great point that it's probably not as dark as complete darkness, which you'd find in the cupboard where I stuck the sagebrush seeds to germinate.
Thank you. A listener named Terry was wondering if you could mention again your results so far of the scarifying and dark burst light.
Sure. So so far I've looked at the data more of in an exploratory manner. So I've generated a lot of different graphs and tried to just sort of look at the patterns that I'm seeing, and then I'll be running them through a statistical analysis to tell me if there are significant differences there between different treatments. So I haven't seen any obvious patterns yet in overall germination, number of seeds germinating, improving that, but I have seen patterns in this germination period. So if we're just looking at this again, what I think we're seeing here is that scarification is decreasing the germination period, and it's only by like 1 day or so in these dark conditions. So if you look at 0 weeks of cold stratification, it's the first 2 bars, and the no stratified, which is given, or no not scarified, which is given by the N, and the yes scarified, which is given by the Y. You just look at the 2 dark bars, and the dark bar under N and the dark bar under Y, you can see that it's smaller, it's a lot lower by 1 day. So it's the germination period's decreased by 1 day in dark conditions. But if you look at the light bar, you can see that it's still sitting about 3 days, no matter if you scarify or not. And if you just go along and you look at these groupings at 5 weeks, at 10 weeks, at excluding 15 weeks, this pattern is pretty consistent throughout throughout the results I'm getting, no matter the age of the seed or the seed lot as well.
Awesome, thank you. We have a couple questions about citizen science. A listener named Christopher would like to know if there's any room for citizen science where they can raise some sage at home and donate it to Grassland.
Oh, well, that's interesting. I think that I might not be the best person to answer that question, because Grasslands National Park is, obviously it's a national park, it's managed by government, and they have a lot of different rules and regulations that they must follow when they're bringing any new seed or any plant species into the park. So they essentially have to be able to say with certainty, you know, where that seed originated, and like look and make sure there's no weeds, all these sorts of things. So if citizens were to do that, I feel like they would have to first, or if they wanted to do something like that, they should contact Grasslands National Park first. And I'm sure there's many different ways that they could contribute, and whether that's by growing out sagebrush that they got seed possibly from the park, that could be an option. But I'm not affiliated with the park professionally, like I'm at the University of Alberta, and I don't want to speak on their behalf that way, but I'm sure they'd be very open to receiving help, for sure. This is a large project, and the more people that care and want to help out, the better.
Awesome, thanks. A listener named Tracy would like to know about how we can find out about the volunteer planting event.
Right, so the volunteer planting events, they're actually advertised on, I think actually PCAP sometimes will advertise those for us. We also advertise on the Parks Canada Grasslands National Park website, but a lot of this stuff actually comes through Facebook and Twitter. So if you follow Grasslands National Park on Facebook and Twitter, you probably be able to be notified of that. As well, I believe that there's a volunteer mailing list going out of Grasslands National Park. So if you were to email the park and ask to be put on the volunteer mailing list, then you're going to be able to receive any notifications about volunteer opportunities, whether that's for volunteer planting events for the Greater Sage-Grouse habitat enhancement, or Greater Short-Horned Lizard monitoring events. So there's a lot of things that are going on in the park. Greater Sage-Grouse is not the only endangered species, and volunteers, there are volunteers coming in and out of the park all summer, and the more the merrier, I think, in this case.
Awesome. I actually volunteered last summer and connected with Autumn about this presentation, and I really enjoyed the day out to go and plant sage. It was really fun. But back to business. A listener named Ryan would like to know, to what do you attribute the decline in sagebrush habitat quality, assuming the land was not broken and has been only lightly grazed for many years? And do you have any advice for land managers within current or former sage-grouse range who wish to enhance existing sage steppe habitat on their own lands?
Wow, okay, that's a really big question. So I may, Caitlin, I might come back to you and just to make sure I'm answering it properly.
Okay. The first part is, what do you think is the decline in sagebrush habitat quality?
Right, and I believe he was saying on areas that have not been broken or anything like that. So I think one of the things about the Greater Sage-Grouse sort of issue is that there's so many different factors that could be contributing to its decline, and you can't isolate them. They've happened in the past, so it's really hard to say what was what, and that's sort of a similar case, I think, to the habitat as well. There are a lot of different theories, and unfortunately, I don't think we can actually go back in time and test them out. One of those, the prominent one, is I hate to use the buzzword, but it's climate change. You know, there's increased drought now. There's also one of the things that it's interesting. The land might not have been broken, but someone has suggested that the hydrology in these areas is very different because of just moving rocks around on the landscape. When homesteaders have moved rocks so that they can keep water from flowing downhill from where they were homesteading, for example, or having their gardens. So even just diverting water in this watershed area in one spot can then have implications for other areas where the land might not have even been broken before. It's just that the water's then not actually reaching that area, flowing in that area as much as it did before. As well, even if the land's not particularly broken or hasn't been broken, species composition could be affected by just invasive species coming in, either by wind distribution from other areas that had been broken or seeded. And invasive species such as a brome and the cheatgrass, they're actually pretty detrimental to prairie, I guess, ecology in a way, because they perpetuate that fire cycle. So they burn very easily, and after the area has actually burned, they're one of the first to come back and colonize. So they're actually using fire as a way to edge out all these other native species, and then that obviously then decreases the sage-grouse habitat quality, because you don't have these forbs coming in and the native grasses that the grouse rely on. Long story short, so that's a long-winded answer, is that I think there's many different things that could decrease habitat quality incrementally on their own, like very marginally, sorry, on their own, but when they're combined, it can have a larger effect. And Caitlin, sorry, what was the second part of that question again?
The second part is, do you have any advice for land managers within current or former sage-grouse range who wish to enhance existing sage steppe habitat on their own land?
Right. I do have some advice, and that is actually to get involved with organizations such as the Prairie Conservation Action Plan, the South of the Divide I think it's South the Divide Action Plan, and they're yeah, they're really great organizations that have a lot of knowledge and a lot of hands-on experience helping landowners come up with ways that they can do this. I definitely wouldn't want to suggest anything to anyone without first seeing, seeing the land. And these kind of organizations, they will come out and do that and help people out. Caitlin, I'm not sure if you can maybe speak more to that.
Yes, PCAP has an event that goes on in February, 2 of every 3 years. So it's going on in 2018 called the Native Prairie Restoration Reclamation Workshop. And, we're trying to reach out to land managers about, best grazing practices, invasive species. We have like hands-on learning activities, like an actual case study where you can run through different scenarios. So it's kind of a great way to learn a little bit more and kind of get your foot in the door too. And it's great for people who've been in the restoration or reclamation field for a long time as well. The Native Plant Society of Saskatchewan also has some great resources for people who want to convert cropland back to native prairie, or even just build a native prairie garden, or kind of enhance their own land. There's quite a few resources, but definitely the South of the Divide Conservation Action Program, or SODCAP, has resources out there too. And they're a new organization that that anyone can look up and get some information, but they are more focused on sort of the south of the divide, so kind of the southwest area of Saskatchewan. Yeah.
Great.
Thanks for your answer, Autumn. There's a question here from a listener named James. How much does sagebrush depend on GRSB for its own survival? I'm thinking of guano as nutrient source for the plants.
Oh, okay. Well, that's an interesting question because, yeah, when we think about ecosystems, it's never really a straight line from one species to another. It's always this complicated web and how things interact. And yeah, thinking about how the sagebrush might rely on the grouse for its survival as well. It's a really interesting idea. And the short answer is that I'm not really sure. I haven't come across very much literature on that subject. A lot of it is just focused on the grouses needing the sagebrush. If I'm going off of what I know about in that area, I would think that one thing that I think the grouse actually can contribute to the sagebrush's survival is that it's just like when you have a farm with chickens and things, the grouse do scratch at the ground to get at these invertebrates. And so by working up the soil surrounding these sagebrush plants and sort of clearing out this area a little bit, it could actually help improve the seed contact. So seed from the sagebrush, it could improve its contact with the soil within that area, which would then improve its chances of germinating and growing into a larger mature plant. Because one of the things that impedes sagebrush from germinating from seed instead of via these, or reproducing from seed instead of these underground root systems, is that if the seed can't reach the soil, it's not going to germinate. In a lot of areas, you have a lot of litter, there's a lot of grass cover, so that's one of the main things that prevents it. I don't think that the, I guess the droppings of the sage-grouse
Awesome. Thanks so much, Autumn. There's another question about when do you anticipate your research will be done and when will it be available?
Right, so as Caitlin mentioned, I'm actually just finishing up this December. I'm finishing the second year of my PhD, and so I have 2 more years to go before this whole project is wrapped up. But the results will be available via publications or scientific manuscripts or scientific papers throughout the experiment, or throughout this 4-year period. So right now I'm actually currently working on writing up the results of this seed germination experiment. So hopefully that will be out next year. And so as the experiments get completed, these manuscripts will be put out, and in the end, though, my thesis should be published in at the end of 2019 or early 2020, and that's where you could find a lot more of the nitty-gritty details, I guess all the methods that I did and how I did things and the rationale.
Right on. I'd also like to mention that Autumn will be talking at PCAP's event in February, the Native Prairie Restoration and Reclamation Workshop. She'll be doing a presentation there at the breakout session. So I think this brings us to the end of the questions. I would just like to thank all of our sponsors today, and that would be Eco-Friendly SAS, SAS Health, and Rancher Stewardship Alliance, Inc. I'd also like to thank Autumn for the really interesting presentation. I know I learned a lot, and I'd like to encourage everyone to connect with Autumn about how they can participate in her research. I'd like to thank all of our listeners out there for attending the webinar today. After this presentation, you will receive an email with a quick questionnaire, and it just takes 1 minute. If you don't mind filling it out, we would really appreciate it, and that would give us some leverage for funding for the future. And please feel free to check out upcoming PCAP events on the PCAP website, www.pcap-sk.org. Click on Communications and Native Prairie Speakers Series. So with that, thank you everyone, and have a great rest of your day. Thanks, Autumn. Bye.
Thank you. Bye.